physics-13.1D. Recognize and use the equation A equals to -2 omega squared times x as the defining equation of simple harmonic motion. Question 1. What does the equation mean? Question 2. The two graphs of xt and at tells us that A is proportional to x. Question 3. How to understand the constant of proportionality is the square of omega in the equation. Question 4. What is simple harmonic motion defined? So what does this equation mean? This equation shows that acceleration A is proportional to displacement x, and the constant of proportionality is the square of omega. And this minus sign shows that acceleration is in the opposite direction to the displacement. For example, if an object in simple harmonic motion oscillates left and right, when the object is displaced to the right, the direction of its acceleration is to the left. So the acceleration is always directed towards the equilibrium position. In another word, the object is always forced to return to its equilibrium position. And this equation also shows that the frequency f or the period t is independent of the amplitude, because we know that the amplitude as the maximum displacement can and may change in a simple harmonic motion, while omega as a constant remains the same. And omega alone determines the period t by the equation that t equals to 2 pi divided by omega. This is also consistent with our intuition and with our experience. Imagine an object is doing a simple harmonic motion. In reality, we'll see the amplitude of the object decreases gradually as this oscillation system is losing energy due to friction. So the amplitude is becoming smaller and smaller, or to say the displacement becomes smaller. So it seems that it will take less time for the object at the position of amplitude to return to its equilibrium position. But actually, if we have a smaller displacement, we'll have a smaller acceleration according to this equation. So the object accelerates more slowly. As a consequence, the time taken for the object to return to its equilibrium position remains the same, which means the period remains the same. P.S. This is also the principle of the pendulum clock. Now let's move on to question 2. The xt graph and the at graph do indicate that A is proportional to x. So this is the xt graph, and over there is the at graph. As we can see, at graph is upside down compared to the xt graph, and this shows that acceleration is proportional to displacement. Or to be more accurately, acceleration is proportional to -2 displacement. Now let's move on to question 3. Why the constant of proportionality is the square of omega? Does this surprise you? It actually makes sense. On one hand, we can deduce the equation, and it's simple. The derivative of the derivative of xt function is the at function. Then compare it to the xt function. We'll get the equation of A with respect to x. I'm not gonna do this here, but I encourage you to pause the video and do it yourself. On the other hand, we can have a qualitative understanding. Imagine a mice hanging on a spring so that it can vibrate up and down. If the spring is stiff, the force on the mice will be greater. It will be accelerated more for a given displacement. So it takes less time for the mice to travel this given displacement. This means its period of oscillation will be smaller, so the angular frequency omega will be greater. In general, if the spring is stiffer, the constant of proportionality in the equation will be greater, so will be the angular frequency omega, and this suggests that omega relates to the constant of proportionality in the equation, and they are positive correlated. Now for the last question. Simple harmonic motion is defined as follows. A body executes simple harmonic motion if its acceleration is directly proportional to its displacement from its equilibrium position, and in the opposite direction to its displacement.